Okay, so you're learning a new number today. What you already know is you know that pi represents 3.14159 going on forever. And you already know that I is the square root of -1. So now you're thinking, why does she have a new number to teach us? Well, I do. So the new number is called E. And the value of E is, you're going to love this, 2.718282845, and then it keeps going. It does not repeat. It does not terminate. So that means this is irrational. Just like pi is irrational, this is irrational, okay? Now, there's a key on your calculator for this number. It's two places. So if you look at your calculator, and this is the one I have to refer to, regular E is located, where am I looking? Where's the division key? All right, right above the division key. You see the E in blue? Okay, so if I wanted to access that E, I'd have to hit the second key first. Okay? Another place that there's an E on here is above the key that says LN. You see that? Oops, hold on. Above the LN key, it says e to the x. That's the key you would use if you're raising e to a power, which you most likely will be doing. Okay, now, e was made a constant when this man, Jacob Bernoulli, tried to find the value of a calculus limit. That's where it comes from, okay? Why do you need to know it? Well, all the things we talked about with our growth rate and all that are great for things like car value and those kind of things, but living things don't grow in chunks. Living things grow continuously. For example, bacteria doesn't grow in 1 hour intervals. We might study it that way because it's easier to measure them in 1 hour intervals, but it grows continuously. Plants don't grow on daily intervals. Plants just keep growing. It's just that the growth is so slow you can't see it instantaneously. So that's why we tend to talk about plant growth in days or weeks. But the reality is living things grow continuously. And sometimes your money does too. So we have a formula for continuous growth or compounding continuously. This is the formula. Oh, I've lost my marker. You may have heard people say PERT. It's the PERT formula, P-E to the RT. Now you need to know what these things stand for. Well, Y is the new amount. Oops. After a time period. P is the original amount. E is the new number I just taught you about on your calculator. R is the rate as a decimal. And T is the time. Okay? So pretty much again, you're just going to be pulling things out of the problem for the formula. Okay? Here's your example. Leave that up there. So it says I have $3,000. I'm putting $3,000 into an account that has 2.5% APR, and I want to know how much I'll have after it compounds continuously for 3 years. So because the word continuous is in there, that's telling you to use the PERT formula. So you're looking for the new amount of money. You have $3,000. Easy. and then you are raising it to the rate times time. So your rate, 2.5%, you're going to use 0.025 times. You are putting this in here for 3 years, so times 3. Again, if you have the TI-83 calculator, you just put this whole thing in. If you don't, you have to do it in steps. So your steps would be first do this. So you're going to have 3,000 e to the 0.075. Now on your calculator, you have to turn it sideways to access the e. I mean, not your calculator, on your phone. And I will show you that. Where am I? Calculator. Sideways. Okay. Wait, why can't you see that? Okay, see how? I can't see it. This way. It's this key right there above my finger. That says e to the x. So after you do the 0.75, you would want to do e to the 0.075. So how do I do that? No. Okay, so when you do that, you have to hit, for this in your phone, on the phone, you have to do 0.075 and then hit the e to the x key. All right? And that's going to give you a big messy number because e is a messy number, so it returns messy numbers. You got to carry that out pretty far. So you're going to carry that out. You're going to have 3,000 times 1.077884115. Then you're going to take that number and you're going to multiply it by 3,000. And you're going to get, now remember this is money, so we're going to cut it at the penny here, $3,233.65. Okay? Again, if you have your calculator, you could just plug it right in. The blue ones work like that too. As long as you have parentheses, you're good. Okay, the next example, I'm giving you the equation. And the equation is this. $30e to the 0.166 t. And this is representing Mycobacterium tuberculosis growth. Don't know what that is. All right, so what we're going to start with is how many cells did the sample start with? Well, if you remember the formula, it's y equals p e to the r t. The p is how much you started with, so p is 30. So you started with 30 cells. The next question says, what's the percentage rate? So here's the R. The R lines up with that number. So 0.166, but we have to turn it back into a percent. That's going to be 16.6%. And then C says, how many cells will you be present if the experiment starts at 1 and ends at 4? So between 1 and 4, there are 3 hours. So you're going to replace the t with the number 3. So you're going to have 30 e 0.166 times 3. And then again, you're going to have to do it in parts if you have a phone. If you have a calculator, you just plug the whole thing in. So you're going to have, if you're doing it in parts, 30e to the 0.498. And then in the calculator, I have to do, well, in the phone, I'd have to do 0.498 and then hit the e to the x key. And you're going to get 1.6, so you can have 30 times 1.645, 4, 2, 7, 1, 2, 3. Okay. And then you're going to times it by 30. And you're going to get 49.363. Now, that means you have 49 complete cells and then something that's partially forming. So depending on the way that you were asked, you could say it's that, or you would say 49 complete cells. All right? Now, the only other thing I think you need to know is that your homework tonight is going to consist of problems like this and also problems like the other day. You got to tie it all together. Make sure you can do all of them. Have a good day. See you later.